So we have a pretty short lecture today. We're going to take and add some vectors, and we're going to start by doing this in component form. What I thought I'd do is I'd do it geometrically first and then show you the algebra behind it. They kind of follow hand in hand. So if I take a vector 5, 3 in rectangular form, I'm going to take and start on my coordinate axis and find the point 5, 3, put a little dot there, and then draw my vector going from the origin to that point. Now, we add vectors using what's called a tip-to-tail method. So there's our first vector, and what we're going to do is we're going to create this fictional axis off that tip, and we're going to plant right on that the tail of this new vector b. So now I'll take and from this point go over 2, down 1, and as I said, connect the tail of that to the tip of the previous. So here's my other vector. Now, the sum of the two vectors happens to be the end result of starting at the first vector's tail and moving to the last vector's tip. So my solution in this case is going to be this vector here. Okay, and this red vector is something we call the resultant. And it has a rectangular component form of 7 over and 2 up. So my solution is 7 over and 2 up. And you'll see, like I said, the geometric and algebra kind of work hand in hand. You'll see that if I just add the x components to the y components, I get my resultant. So it couldn't be much easier. Oops. So let's go ahead and do just a couple of quick ones. Now in this case, we have two vectors given to us, b and c, and we're asked to find the resultant of these two forms here. So what I like to do is I like to just take and find out what 2c would be. We talked the other day about doing scalar multiples on rectangular forms, so 2c would be equivalent to multiplying 2 by each of these two terms, giving me a 2 and a negative 4. And then we take a look at b. That's just negative 3 and 7. And like in our previous example, we're just going to take and add the x components and the y components and get negative 1 and 3. And that's my resultant. So then on the next one, we'll take a look at 2b. And that's equivalent to multiplying 2 times the components of the b term. So 2 times negative 3 is negative 6. 2 times 7 is 14. And then when I subtract, it's the same as multiplying by the negative and adding. So I'm going to look at negative 5c. Multiply those components by negative 5, giving me a negative 5 and a positive 10. And then I'm just going to add those up, getting negative 11 and 24. And there's our resultant there. So like I said, adding in rectangular form couldn't be much easier. You're just taking and adding like components. Now, the difficulty comes when we have a situation where we have polar coordinates. So in this case, I'm adding the two vectors a and b, where a is a polar coordinate of 7 and 20, b is a polar coordinate of 2 and 70 degrees. I'm just going to sketch this out real quick. It's not going to be super accurate, but you get the point. So if I were to take and add a vector that's 7 long and 20 degrees on a rotation, just say that's right around here, and the geometrical concept of this is the same as the geometrical concept of adding component forms. You add tip to tail. So now, again, I create this fictional set of axes on this guy's tip, and I'm going to take and add the vector 2 at 70 degrees, which is going to be something like that maybe. So my resultant goes from this guy's tail to this guy's tip. And as you can see, there's no way we're adding components here, because if I added components, I'd be at 90 degrees, and clearly I'm not. So there's got to be something to this. Well, the best way to do this is convert to rectangular and add. So the steps involved in doing this is, one, you're going to convert to rectangular. Two, you're going to add or subtract. Three, convert back. And be done. So let's go ahead and do that. We talked the other day about going from polar form to rectangular form back and forth, and we found out that x was equal to r cosine theta and y was equal to r sine theta. So I'm going to do that for both of these coordinates. So a in rectangular form is going to be 7 cosine 20 degrees and 7 sine 20 degrees. Oops. And then b in this case will be 2 cosine 70 degrees and 2 sine 70 degrees. So now it's just a case of plugging it into your calculator, making sure you're in degree mode. And I'm going to take and just add these while I'm at it, so I'll throw a line down here. And my first sum of these two coordinates is going to give me about 7.26. And then my second term will give me about 4.27. Now let's remember, this is in rectangular form or component form. So now what I'm going to have to do is I'm going to have to go back and convert, because they're going to want my resultant to be in polar form, or some r followed by theta. And we did that conversion as well. Remember, we had x squared plus y squared is equal to r squared. And we had the arctan of y over x was equal to theta. So let's just go ahead and do that. I've got 7.26 squared plus 4.27 squared, all rooted. And then I'm going to have the arctan of 4.27 over 7.26. That's going to get me about 8.42. And then I do my arctan calculator, which yields roughly 30.46 degrees. And if you look at the graph that we initially did, you'll see this is a little bit longer than 7, so maybe 8-ish. And if we started out at 20 degrees, again, not super accurate, but we've gone up, a little bit more degree-wise, and it's a rough representation of the mathematical case that we've got right here. So that's really all there is to it. It's just everything goes back to component form, because that's the easiest thing to deal with. All right, that's all we've got today, and we'll see you tomorrow.